We've seen how to build power series representations of some functions already. So far, all we've really looked at are functions that have the form a over 1 minus r. That's where, the form of the function is the sum of a geometric series. We've done those functions. We've done a couple of closely related ones like arctan and natural log of 1 minus x. Both of those functions are things where the derivative has the right form. So a good question is, can we find power series representations of other functions? And the short answer is yes. This is a chart of Maclaurin series. It's in the textbook on page 762, and this is the series representation of a bunch of different functions. Now this first one here is what we've already been doing. 1 over 1 minus x has the form we were talking about before, and so your first term is 1, and then the rest of your terms are just multiplied by x each time. So what about other things? Well, this gives us the different series for e to the x, sine x, cosine x, inverse tan, natural log of x, and this other one. Now over here where it says r, this is the radius of convergence. What that means is these are all centered at 0. And this tells us, the r tells us how far out the approximation is good for. For this one, it's only good for a radius of 1, so from -1 to 1. Same thing for these. But the ones where it has infinity, it means that the approximation is good for a radius of infinity, so from 0 up to positive infinity and from 0 back to negative infinity. So let's look at these and just convince ourselves that these series actually represent these functions. Let's start off with e to the x. The series for e to the x looks like this. Now, if I take this, and if I take the derivative of it, so the derivative of this I'm not going to write all that out. No, that's not a good use of time. Let's take the derivative of this series and show that we get e to the x back.